Yo, yo, yo! This is Mr. Tran with another chemistry video. Today we're going to expand our knowledge of pH and how to calculate pH. So please be sure to get your graphic organizer out from last week, some notebook paper, and a calculator. You can use your phone. Pause this video now if you need to grab those things. I'll wait. Good. Let's turn your graphic organizer over to the second page. I want you to cross out the top half where you see naming sections. I want you to start in the area located underneath what is pH. I want you to write self-ionization of water. I repeat, self-ionization of water. All solutions have some hydrogen ions and hydroxide ions. This is because water self-ionizes. Let's write the self-ionization down. We have H2O plus H2O yields. Remember, according to the Bronsted-Lowry definition of acid and base, one hydrogen is being changed. So, I'm simply going to pick the first water and make that water lose a hydrogen and the second water gain the hydrogen. This makes the first water become OH minus and the second water become H3O plus. Let's remember, y'all, that the H3O plus, the hydronium ion, is the same as a hydrogen ion, or H plus. Again, H3O plus is the same as H plus. With that concept in mind, let's define pH. Beneath the self-ionization of water that you just written down, please write down the following. pH is a measure of the concentration of hydrogen ions. We can shorthand that concentration of hydrogen ions with hydrogen ions in brackets. The bracket, y'all, represents concentration. pH can be determined by an equation. The formula is pH is equal to negative log of the concentration of hydrogen ions. Whoa, whoa, whoa! What is a log? Let's just say it's simply another way of thinking about exponents. There's a video from Ms. Flores on what a log means that you should have watched before this. But the bottom line is that you can find this expression, log, on your calculator and use it to find pH. This log expression makes the formula say that the pH and hydrogen ions are inversely related. Okay, pH and hydrogen ions inversely related. Remember, inversely related simply means that if one goes up, the other goes down. So, in terms of pH, if the solution has low pH, we know that the solution will have a high concentration of hydrogen ions. We know that water self-ionizes, so we also know that there should be some concentration of hydroxide ions. Because there is a high concentration of hydrogen ions, there therefore must be a low concentration of hydroxide ions. The reverse is true as well. For something that has a high pH, a solution with high pH, we know that the solution should have low concentration of hydrogen ions, but a high concentration of hydroxide ions. Let's make sure you guys write this down. Underneath your definition of pH. It is inversely related, and these are direct examples of what this inversely related means. Now, let's look at the right-hand side of your graphic organizer. Do you see the box on the slide and the replicated box on your paper? Well, I want you to copy it down now. Copy all of the details. Please pause the video now so you have time to do so. I'll wait a little bit. Good. So, let's talk about the pH scale. It goes from 0 all the way to 14. A pH below 7 describes an acidic solution, whereas a pH of above 7 describes a solution as being basic. A pH of exactly 7 is considered to be neutral. I want you to write the special note down. Okay, so this pH looks like it's approximately at pH of 2, which is a low pH. Let's see what happens at a low pH. I have a lot of hydrogen ions, but there's a very small amount of hydroxide ions as well. So even for a low pH, there's still a small amount of hydroxide ions, the OH- ions. Be sure to draw the dotted line to reference this note, okay? The dotted line you guys see there. And the reverse is true for a very high pH. So say pH of 12. We still have this area, y'all, of hydrogen ions. So very high pH, there will still be a small amount of hydrogen ions. Now, going back to the left-hand side of your graphic organizer, fill in the table that you see in front of you. I promise all of the squares will fit. I suggest pausing to copy this table down. I'm gonna wait a little bit for you to pause. Good. So let's look at each line here, y'all. What does acidic, basic, and neutral mean in terms of the concentration of hydrogen ions and hydroxide ions? For neutral, it simply means that the concentration of hydrogen ions is equal to the hydroxide ions. For a solution to be considered acidic, the concentration of hydrogen ions must be greater than the concentration of hydroxide ions. A lot of hydrogen, a lot of H is acidic. For a solution to be considered basic, the concentration of hydroxide ions would be much greater than hydrogen ions. That again, to be basic, the solution needs to have a lot of OH- ions. Just like we've written down before, it is true that acidic solutions contain small amounts of hydroxide ions, and basic solutions contain small amounts of hydrogen ions. And again, let's write it in terms of pH on the side. So this would be 7. This would be less than 7. This would be greater than 7. Now moving on to calculating pH. So what we have here on the left-hand side is your iPhone. And if you were to open up your calculator app and turn your iPhone to the horizontal orientation, and that's the one you see here on the screen, you'll be able to access the scientific calculator. In order to find pH on your scientific calculator on your iPhone, what you need to do is to type in the concentration number first, then hit the equals, then hit your log button, and finally finish it off with a negative. Then you will have a positive pH number. Let's look at some of the examples on the next slide. Let's find the pH of the following solutions. Number 1, this solution has a hydrogen ion concentration of 1.2 times 10 to the negative 4. So in order to find pH, I need to type in 1.2 EE -4, then hit my equals, then hit my log, and finally negative to get 3.9. So we see here that I rounded my pH. Again, there's no true sig fig rule for pH, so I'm just going to use the fewest sig fig of the given number. So that is 2 here. Number 2, this solution has a hydrogen ion concentration of 5.4 times 10 to the -9. So that's what I type in first. I type in 5.4 EE -9, then hit my equals, then hit my log, and then finally negative to get 8.3. Last but not least, number 3. This solution has a hydrogen ion concentration of 9.8 times 10 to the -2, and that's what I type in first. 9.8 EE -2, then equals, then log, and then negative to get 1.0. POH? What your what? Yes, that is a thing. Just as pH is a measure of the concentration of hydrogen ions, POH is a measure of the concentration of hydroxide ions, OH-. We can simply replace the hydrogen ions with an hydroxide ion, and we have the equation to get POH. To solve for POH, simply type in the concentration of hydroxide ions, then log, and then negative. We know that the pH scale goes from 0 to 14, with any value less than 7 being acidic and any value greater than 7 being basic. Let's think about an acid. We know by now that an acid has a lot of hydrogen ions and a few hydroxide ions. That means we can get a pH value for that acid as well as a POH value for the same acid. If we were to add the values together, the pH and POH values, we should get 14. I want you guys to write that equation down. pH plus POH equals 14. Let's see how we can apply this equation to a problem. If a substance has a pOH of 6, is it an acid or a base? Because we are very confident in terms of pH, let's use the pH plus pOH equals 14 equation and solve for pH to figure this out. So it says that the pOH, y'all, is 6. So I'm going to be substituting my pOH with a 6. I'm going to subtract the 6 on both sides to get pH equal to 8. Because the pH is greater than 7, we know that this pOH of 6 is a base. In water, a neutral solution, a hydrogen ion concentration is equal to the hydroxide ion concentration, which is equal to this number right here, 1 times 10 to the -7. If we take the pH, y'all, we simply take the exponent and change the sign. We have the pH equal to 7. This is called the shortcut method. You simply look at the exponent, make it positive, and that's the value of your pH. But it is on the condition that in your scientific notation, the coefficient must be equal to 1. Let's write that down. Shortcut equals coefficient of 1. Only then will you be able to look at your exponent and make it positive in order to get your pH. This acid has a hydronium ion concentration of 1.0 times 10 to the negative fifth molar. What is the pH? Remember that H3O plus is the same as H plus. Because I see that 1.0 is the coefficient, which is 1, the shortcut method can be used. So I simply take a look at my exponent, make it positive, and the pH ends up being 5. So the solution should be acidic because the value is less than 7. Specifically, the pH value is less than 7. If the concentration of H3O plus is 1.0 times 10 to the negative 12 molar, what is the pH? Again, we see that the coefficient is 1. So we look at the exponent, make it positive, the pH is 12. So the solution should be basic because the pH value is greater than 7. Given that a solution has a pH of 2.0, determine the concentration of H3O+. So this is the opposite. Okay, instead of looking at the exponent, we have to make the exponent. So I take my pH value and make it negative. Okay, so making it negative here. So that's my exponent. So what do I do with the exponent? I put it into the times 10 portion. So it should be 1 times 10 to the negative 2. That's the concentration of my hydronium ion. What is the pH and the pOH for 1.0 times 10 to the negative 6 molar HF? So what is this concentration describing, y'all? Is it describing the H plus concentration or the OH minus concentration? It doesn't state specifically what it is. So if it doesn't state it, y'all, we definitely have to take a look at our substance, HF. I don't see an OH in that formula, so I know this concentration right here is describing H plus. I see that my coefficient is 1, so I'm simply going to take a look at the exponent and make it positive in order to get my pH. In order to get my pOH, I simply use the equation pH plus pOH equals 14. I subtract 6 on both sides, and I get my pOH to be 8. Okay, y'all. That's all for today. Look for more practice, okay, and work it. Have a good one.